Hello, and welcome to a video about creating real-world periodic situations. Well, I guess not creating them, creating equations to represent real-world periodic situations. So we're going to look at these graphs and the problems and write equations. All right, so the height of the tide at beaches around the country follow a periodic pattern. The graph below represents the height of the high tide at North Avenue Beach, downtown, each week for 52 weeks. So that is a whole year. Now, the first thing we need to decide is whether this is a sine or cosine function. Take a look at the little sketch on the bottom right-hand, almost corner-ish area. To me, the graph that is presented with this problem looks more like the cosine. So I'm going to write down the cosine skeleton. Y equals a cosine of bx plus c. All right, let's see what we have. A is our amplitude, B is our frequency, and then C will be our midline. I think the midline is the easiest one to see, so let's start off with C. In this case, if you take a look at this graph, our midline is at, well, let's see. We go from the highest point at 5, lowest at 1. Our midline is going to be at 3, at positive 3. So I'm going to write 3. All right. A is our amplitude. I think that's the next easiest thing to find, so let's take a peek. The amplitude is the distance between the midline and the highest or lowest point. In this case, if you look, you see that we have 2 spaces between the midline and the highest point, and 2 spaces between the midline and the lowest point. So A will be 2. The last part is the frequency. Now, the way we do this is by doing 2 pi divided by our period. In this case, since we're looking at 52 weeks, we are dividing by 52. That's our period. Now, these are both whole numbers, so I'm going to write them over 1. We get 2 pi over 1 times 1 over 52. We get to reduce the 2 and the 52. The 2 becomes a 1, 52 a 26. And we get an answer of pi over 26. And we are about to be done. All we have to do is plug it into our equation. Let's do it. So y equals 2 cosine of pi over 26x. And since c is a positive 3, plus 3. And that's it. Awesome opossum. Let's do the same thing for the next one. This is the length of sunlight in a day, and it follows a specific periodic function. The graph below represents the length of sunlight in hours over 52 weeks. So once again, we're measuring it over a year. Let's decide whether we're using the sine or cosine function. In this case, it looks more like a sine function. Oh, excuse me. So here's my skeleton, y equals sine of bx plus c. A is our amplitude, b is our frequency, c is our midline. Now, luckily for us, we have the same period as the previous problem, so for our frequency, we have pi over 26 again. I'm not going to have to redo that problem because we just did it. Okay, so all we have left is midline and amplitude. Let's figure it out. Okay, so our highest point is at 14. Our lowest point is at 6. So what's right in the middle? 10. So our midline is 10. Let's find our amplitude. That's the distance between the midline and the top, or the midline and the bottom. And that would be 4. We're done. Aha! Y equals 4 sine of pi over 26x It's a positive 10 plus 10. Voila! We are done. Onwards. We don't have a graph here. Oh, how will we know whether it's sine or cosine? That's the thing, actually, we don't. We're going to write two different skeletons. And that's fine, because all we really need is the A, B, and C. Whether we write sine or cosine doesn't really matter. Okay, so let's see what we have. The length of sunlight in a day follows a periodic function. Yes, we saw that in the last problem. In one particular location, the average sunlight in a day is 9 hours. The difference between the longest and shortest days is 6 hours. Let's write an equation to represent this situation over the span of 52 weeks. Okay, so let's find our A, our amplitude, B, our frequency, and C, our midline. First of all, our frequency is going to be the same as every other problem we've done today, all the other two, because we're measuring over 52 weeks. Beautiful. Okay, next. Average is 9 hours. Average is what you have in the middle, midline. Aha! Okay, beautiful. Now, we need to find out the amplitude. The amplitude is the distance between the midline and the highest or lowest point. We are given that the difference between the longest and shortest days is 6 hours. Now, let's say this is a sine function. I don't know, I'm just guessing at this point, right? But let's pretend because I can draw it a little better. What this problem is telling us is the distance between here and here is 6. The midline is going to be somewhere there. So 6 divided by 2, that's 3 and 3. Right? If the whole distance is 6, split it in half with the midline, 3 on top, 3 on the bottom. So that's our amplitude, 3. Okay, we are ready to write our skeletons. First, let's write I almost wrote an A, a cosine function. Why? Because I feel like it. Positive 9. And I'm also going to write a sine function because I honestly do not know. I do not have enough information to decide whether or not this should be sine or cosine. I hope this was helpful. If you have any questions, please let me know. Otherwise, have a wonderful rest of your day. Bye.